In this video, we're going to be making this scene from scratch, and you can apply the effect to any object you want. It doesn't have to be text. And we're also going to be learning a lot of other stuff on the way as well. And if you want the scene file, you can download it from the members area at 3d-illusions.co.uk. And just before we get started, if you want to learn more about turbo tools and how you can use the turbo render feature to speed up your cycles renders quite dramatically, then check out the links in the description below. Alright, so let's start by deleting everything in the scene. We don't want the cube, we don't want the light. We'll probably keep the camera though, in actual fact. And we'll add some text. So Shift A, text, and we'll go into edit mode and just change this to be whatever text you want. So I'll just go with 3D illusions, back to object mode, right click, and I'll convert this to a mesh. If you want to change the font, by the way, you can do that over here in the font properties. So right click, convert to mesh, back into edit mode, interface mode at the top there. I'll select all the faces, E, and then I'll extrude upwards. What I might do actually before I do that is X, and we'll do limited dissolve. So it gets rid of the unnecessary parts of the mesh. And then EZ, move those up, maybe to about there. Got some 3D text, back into object mode, and I'll rotate it on the X-axis by 90 degrees. And we change the renderer to cycles, and then we'll turn it into cycles viewport mode. And we need to get some lighting and reflections and things, so I'm going to bring up the shader editor, change it to world mode, and I'm going to add a HDRI background. So Shift A, S, environment texture, we'll plug this in, and then it'll turn pink, so we've not yet specified a HDRI image. So open, navigate to whichever HDRI image you want to use. You can download these from a website called HDRI Havens, pretty good one. And then choose the HDRI you want, bring it in, wait for it to load, and then press Ctrl T with this one selected, making sure you've got the Node Wrangler add-on enabled. And then you can start rotating the environment until you get the view that you want. If it's a little bit slow to rotate, like it was for me there, go into the world settings, under settings, change sampling to manual, and then maybe change this to something like 2048. That'll reduce the resolution of the HDRI image for the lighting and the reflections, whilst keeping it the full size for the camera. So when we've done that, rotate it until you've got the look that you want. I'll go into camera view now, and I'll make sure I've got in the end panel under view, lock camera to viewport, and now I can move the camera around as if it's just the same as moving the viewport. So I'll find that angle I wanted before. You'll see it looks different now, and that's because the camera focal length and the viewport focal length aren't the same. Go to the camera properties, and I'll reduce the focal length until I can see more of the environment, or less of it, whichever you want. Then just make any more little tweaks you want to the camera's position. And I'll probably rotate this text now, so it's looking towards the camera. Alright, so let's start adding some particles. I'll change the editor type to geometry nodes. We'll add a new geometry node network, and I'm going to instance some particles on this text. I'll turn off overlays so we don't get that horrible yellow line, and I'll come out of camera view as well now. So Shift A, S, I'm going to do distribute on faces. Drop that in there, and if I set the value quite high, maybe 10,000, we're going to get the particles on the text. The particles are a little bit too big though, so I'm going to Shift A, S, radius, and you choose set point radius, drop that in there, and then we'll control this. We can either do it in here, but for better flexibility, we'll add it to the actual geometry node modifier. So I'll just grab this one, Shift D, bring this over here, make a bit more space, and we'll connect the bottom one into the radius, and now we can control it over here. Now I don't really want all this overlap. I want them to be distributed as evenly as possible so that I don't have to use as many to get the maximum coverage. So I'm going to change this to, instead of random, however you pronounce this second option. It looks like poison disc. I'm sure that's wrong though. And I want the radius, the minimum distance, to be the same as the radius. so they can't be sort of closer together than that. So I'll plug this radius into the distance minimum, and now I need to increase the density max. So I'll put the density max really high, something like 50,000. And now we've got the same coverage near enough, but we don't have as many overlaps, which means we can use less particles. But I want to get rid of these little tiny gaps we've got here, which is quite easy. We just need to make the minimum distance a little bit smaller than the radius that we've selected. It's Shift-A, S, put down a math node, multiply the input that's coming in, the radius, by maybe 0.5 should actually be alright. We could probably try 0.7. You just need to choose a value, but make sure you've got no little holes in the mesh. And if I set the value quite low now, maybe 0.005, we're going to be back to having gaps. And that's most likely because the density is no longer sufficient for the smaller spheres that we're using. Even if we reduce the distance minimum, like say 0.5 or even 0.2, just because the density max isn't high enough, we're still going to get those gaps. So I'll put this back to 0.5, and I want to calculate the density then based on the radius. So I'm going to copy this one, Shift-D, and I want to change it to divide, and I'll plug the radius into the bottom, and this top value is going to be something quite high, like 1,000. So if I put 0.005 in here, we'd get 200,000 particles. Or if we go with 0.5, just to make the math a bit easier, we're going to get 2,000 particles, although obviously they're going to be massive. So I'll put it something like 0.1. If I then plug this in to the density, then we're going to get a maximum particle count of 10,000 divided by 0.1, which is 10,000 particles. And if I keep adjusting the radius, then the maximum density will automatically change based on that divide node that we've dropped down. It just means we don't have to do any manual labour. So if I keep going down, you know, we can get to a point where it's crazy small, 0.002 for example. We're going to get a lot of particles, and we can see how many we've got if we just bring up the spreadsheet. And you can see we've got 1.6 million particles. So much, in fact, that we can't really tell that they are particles, which is what I was hoping for. And if you still notice you're getting a few little gaps, it's probably not going to matter at this distance. But if you did want to fix it, you might be tempted to reduce the radius, the minimum radius, but that wouldn't really have a good effect. What you'd need to do is increase the density max by adding a bigger value than 1,000 on that divide node. But rather than destroying my system, I'm actually just going to increase the radius a little bit. 0.006. And that's probably better because it means we will be using less particles, we'll get a little bit better performance. And also from the distance we're going to be viewing the geometry, it's not really going to matter anyway. But just to be a good sport, I'll try going crazy. I'll set the radius 0.002, and then I'll try increasing that max density by setting this divide value to something like 1,500. I'm on an i7-7700K with 32 gigabytes of RAM, by the way. That gives us 2 million. And we've still got a few very tiny ones, so we could try lowering the radius a tiny bit more, 0.3 perhaps, and that might help a little bit. So a tiny bit. But again, it probably would have been better to increase the max density. But anyway, now we've got 3.1 million particles, which we can't sort of animate in the viewport. It's going to take, we'll be waiting forever between each frame. So we need to create a second version now that's just for the viewport. So I'm going to drop down a node, Shift-A, S, called isViewport. And this will output true if it's the viewport. And then I'm going to say Shift-A, S, switch. We'll drop this in here on this one. And I think we'll just turn this off, the modifier, so we can work more quickly. And we'll plug the isViewport into the top of the switch. And if it's the viewport, we're going to get the bottom one. If it's not, so if it's the final render, we're going to get this lot here. I'll put these into a group to make it easier to understand what's happening. Control G, and I'm not sure what's connected to these new ones up there. That's a bit weird. So what I'm going to do is plug the radius in there, which is what it should have been, I think. Yeah, that's right, radius into that one. And for this one, that should be radius as well, into the bottom. And I'll just check outside the group, see what's happening out there. So press Tab to come back out of the group. Yeah, I'm not sure what happened there. Plug that one in here. We'll get rid of that one. We'll go back into the group, and then I'm just going to delete that bottom input. I don't need that anymore. So into the group tab and just press minus to delete that, and now it's gone. Weird. Anyway, let's go back into the group, and now we'll start plugging in the other bits that we need to control externally. The minimum distance multiplier, this is the one that changes the size of the minimum distance. So I'll rename this to min_dist mult. I want this one to go into here, so this is going to be the max density. So max density mult, or divide. If we come back out, I'll get rid of this group now. I think that was the problem before. We can now make a duplicate of this by pressing Ctrl-Shift-D, and it will duplicate it whilst keeping the connections. And I'll just change these values now so that they're much smaller. So I'll put this one to maybe 500, and if we plug this in to the bottom, we'll turn this on. We're only getting 1.3 million. I can change this to 1. Now we're getting 563,000. And if I want to change the size of the particles, what I can do, Shift-A-S, math, and on here, I'll add this as a multiplier, drop it on there, give it a second, and we'll change this to maybe, let's go with 2. So now the particles are much bigger, we're getting far fewer points. It's probably still too many, so I might go with, let's go with 200. So now we've only got 128,000 points. When we render though, we're going to get the 3 million that we had before, because this will output the top one instead of the bottom one when it's not the viewport. I think I'll make these particles a little bit bigger. It's still quite a lot, so I'm going to change this to, let's go with 4. Maybe even, let's go with 10. So we've got quite big particles. We've only got 7.9 thousand now, so we should get a fast performance in the viewport. I'll go back out of cycles mode. We'll go back into the standard shader, so viewport shading. What I need to do is manipulate these points so they start moving away from their original positions. So what we're going to do, after we've done the switch, we'll do Shift-A-S, and we want to add a position, set position, and we'll drop this in here, and we need to offset them. So if I offset them like this, you can see we can offset them all at once, like that. And to offset them, I'm going to use a noise. So Shift-A-S, we'll put down a noise texture. I'm going to output this into the offset. So now we're starting to get a noisy result which we can control with the scale on here. We can change the detail, which I probably wouldn't do. We can change the distortion. We've got all sorts of different options we can do. And then of course we can animate this over time. But in order to do that, we need to add a 4th dimension, which is going to be time. So I'll change this to 4D. And now we've got this W factor, which will allow it to change. If I plug in Shift-A-S, frame, not frame, Shift-A-S, is it time? Scene time, there we go. And we can plug in the frame into the W. So now when I press play, it's going to keep changing. Now it's a bit too fast, so what I'm going to do, Shift-A-S, math, and we'll say multiply by maybe 0.2. Let's try playing that back. Still too high. We'll go with 0.1. 0.01. There we go, so that's looking pretty good. Now the current problem is, although it might look alright, the particles are all being moved from their current position in a positive direction. I'll just draw on the screen what I'm talking about. So we've got a particle here. How do we draw a particle? How do we draw annotate? Oh, we need to turn this on. Right. So we've got, let's say we've got a particle here. This is the position on the x-axis. So let's say it's a position 0 on the x-axis. So that's the particle at position 0. And then we've got negative numbers this way and positive numbers this way. Now this colour is always going to output 0 to 1. It's going to output RGBA 0 to 1. So it's always going to be moving it. let's say on the x-axis from its current position in this direction, but I want it to be moving both this way and that way, so that the particles move around the original location instead of shooting off in one positive direction. To do that, we need to slide the value. So say it outputs, say this colour outputs the x value as 1. I want it to move it to 0.5 on here, and if it outputs 0, then I want it to move it back to negative 0.5. So basically all I need to do is subtract 0.5 from all of the values at this output. So we'll do Shift A, S. We need to do a vector math because it's 3 values. Shift A, S, vector math. We'll plug this one into the top, and now we'll just say subtract 0.5 from each of them, and then we'll get the movement going in both directions instead of only in one direction. Let me just get rid of that annotation. That's the first time I've ever used annotations in a tutorial. That's a good idea. I think I need to get a pen though, it's a bit difficult with the mouse. Anyway, we've got some movement now, and if we just play it back, I'll turn the overlays off again. You can see we're getting some nice movement on those particles. Now, what I'd like to do is do this multiple times so that we can have different noise patterns modifying the geometry. And we also need to get it to sort of fly around as well. I also want to change the scale of the displacement of each point. We can't do it with the scale here because that's just the scale for the noise itself. So what I'm going to do, Shift A, S, again we'll choose a vector math, add this here, I'll change it to multiply, and then Shift A, S, I'll add a value node. In fact, rather than a value, we'll bring this group input across and make it adjustable directly in the modifier. So we'll wire the empty socket up to the vector. Then I'm going to change, I don't want it to be a vector, I don't have to control all 3, so I'm going to change the type to a float, and now we've got one value only. And I'll rename it to noise 1 displacement. And then we can modify this to get them to come really far out like that. So I'm actually playing that back, that's why it's moving all over the place. I'll just stop the playback so we can see that a bit more obviously. So we're basically just multiplying whatever comes out of here so that it goes, further away from its original position. And we can just see if I mute this subtract, what happens. You see it's just moving away in one direction, which is why we needed this subtract. So unmute that. Now it will stay in place and it will go negative 0.5 to positive 0.5. Essentially making sure it stays in place. So to make this network reusable, I'm going to put all of these into a group. So Control G, we'll come back out, and I'll just rename this one in the node panel to, what should we call it? Just noise 1. And then we can do Shift D, add this again, then we'll make a duplicate of the group input again. And I'll plug this one into the vector, and we'll go across to the group properties. I need to change this again to be a float, and I need to rename it in the group input to be noise 2 disp. And now I can control the second noise like so. But obviously I'm going to want to be able to control not only the size of the displacement, I want to be able to control these options on the noise as well. So I'll connect all the ones I want to be exposed to the front end of the group, to the group input. And I also want to be able to control the speed as well on the multiply node. I'll rename this one to speed. And I'll come back out, and now we've got these additional options. So if I change the scale on this one, I'll just rename it so it's noise 2 on the label. Then we can play about with the settings for the displacement on the displacement strength on the modifier, and we can also tweak the settings for the scale, distortion and speed on the group front end as well, so that we're effectively combining 2 noises to get really interesting results. Then we can just tweak the settings until we get a result that we like. For the second one, I'm going to go with a larger noise by decreasing the scale on the noise so that we get more of a large wave sort of movement. And I'll also increase the displacement as well to make it a bit stronger. So we've got micro movement on this one. So if I turn this off, you'll see we're only getting this one. If I turn this one off, that's the difference. Maybe we could turn that up a little bit higher, perhaps. And then turn this one back on. That's the result we're going to be getting. And then we'll finally go with perhaps one more. Copy both of these, Shift D, bring them across. And I'll plug this one in here, this one in here. So we've got 3 noises now. I just need to rename this one to noise 3. And then we need to change the vector to be using the bottom one. And then back in the group, change it to this one to float, the new one. So we've only got one property to change again. And we'll rename it noise 3 disp. And I'm also going to expose the scale, distortion and speed of each of these noises to the modifier. So let's quickly do that as well. So I'm just going to tweak all of the noises now. I'm not going to spend too much time on it because I'm probably going to need to tweak them again later anyway. But just to get a rough idea, I'm going to make the second noise sort of not as small movements as the first one, and then I'll make the third noise even bigger wavy movements. So we get sort of a nice mixture of 3 different types of noise. Now what we need is an easy way to turn all of the effect off so that we can animate it in turning back into text very easily. So I'll just go back into rendered view, looking pretty good. Now I want it to be able to turn it, as I say, I want to turn these all off at once. So I'm going to add a master displacement amount. So we'll come inside one of the group nodes, and we can do it inside any of them because all 3 are using the same group. So any changes we make inside it will reflect onto the others as well. What I need to do is just find the value that I need to modify, and it's going to be the vector one, the top one. So I should probably just rename that to be displace amount. I want to be able to turn this off for all 3. So I'll just do Shift A, S, vector math, drop this on this one, make it multiply, and I'll expose that to the group's front end, and then I'll rename it to master displacement. And I want to change it again to be a float, so it does all 3 of those inputs at once. The default's going to be 0, so we're going to get nothing happening in the viewport now. So if we come back out, I want to connect this to the group input. So now at the bottom, we can control all of the movement with this one slider. So if I turn this up, we start getting the movement happening. And if we press play, then we'll see it. Let's just go back to this mode. So we've got playback happening. If I turn this up, we can control that coming in and out. There we go. So we only need to animate this one slider. So next up, we need to give it a material. If we go into rendered view again, we can see it's pretty boring to look at. There's no color on there. So I want to add a material using the material editor. So N, I'll drag a new material editor across here, change this to shader editor, change it to object, and then we need to add a new material. And let's just change the color. Nothing's going to be happening because we need to assign this material inside of the geometry network. So I'll just name the material over here to particles, and then with Shift A, S, set material, and I want to change it to particles. And now this material is going to be used for whatever is output from this entire tree. Now I don't want them all to be the same color. I want to be able to modify the colors based on the actual what's happening with the noise. And I think I'm probably going to use the first noise, I think. So I press tab to go back inside the group. And I'm going to output the factor of the noise to the group output so we can access it outside the group. We'll just output from 0 to 1, so we'll do it before this. Then we'll plug this one in here, and we'll just tidy it up a bit. And then we'll come back outside of the group. We've got to add the attribute outside the group, otherwise all three would be right into the same attribute and they get overwritten. So Shift-A, S, named attribute, I'm going to say store a named attribute in the geometry. And I want the attribute to be a float, that's fine, because I'm using 0 to 1. So I'm going to use this as the value into the bottom, and I'll call it noise1. So noise1. And if we look over here now, the points, we should have got a new attribute, noise1, and this attribute name is going to be available in the shader editor. So Shift-A, S, attribute, and we'll choose the attribute on the geometry, and it's going to be noise1. And if we just isolate this node so we can see it on its own, we can see that each point is now getting the color that we created from this noise in the attribute and restored over here in the spreadsheet. So each point's got a unique value between 0 and 1. And we can use a ramp, Shift-A-S ramp, to make that a bit more harsh, a bit more contrasty. And then we can probably use this, Shift-A-S, let's go with a mix for now. Mix color, we'll drop that in there. We'll plug this into the factor so that the black areas get the top one, A, and the white areas on this map get the bottom one. So I'll make the top one red, and the bottom one green or yellow or whatever. Now we can control the strength with these sliders on the color ramp. We'll plug this over here into the base color, and now we'll plug this one into the material output, and you can see what sort of an effect we're getting. And if we try playing this back, so the noise is actually going to be changing all around the object because this noise, noise1, is being animated by the frame. So that's pretty cool. We've got sort of a animated material going over an animated mesh. And if we turn up this master displacement, we can start getting some really interesting effects. And maybe we'll make the scale or the displacement on the third one a little bit higher, and maybe change the, I think the scale on this one, maybe to bring that down a bit. Nothing seems to be happening when I'm modifying these values. I'm pretty sure I've made a schoolboy error somewhere along the line. Let's have a look. Just have a quick check. Go into this mode. I'm going to turn the first noise and the second one off temporarily. Nothing at all now. You can earn yourself 10 points if you can put in the comments what I've done wrong before I manage to fix it. I can see what I've done. I've not connected the second group, so the master displacement isn't connected to noise 2 and 3. So they're both basically set to 0. There we go. Plug that one in as well. What a moron. There we go. So if I mute this one, this is the result we're getting from the third one. And I can start tweaking these now, the third one, with the other two muted, just so I get a better understanding of exactly what's happening. And you'll see we've got a, if I change this to 0, nothing's going to happen. 1, maybe 50. So we've got a really high displacement now. And then we can modify the speed for the third one as well. Maybe 0.1, make it much faster. Like that. And if we turn all three on now, you can see we're getting this really nice effect. That's with 2 of them on. And if I put this one on as well, then we're getting a really interesting effect. And again, we can just turn this straight back down to bring it back in to the original text. And all of these parameters can be animated over here. Well, for this tutorial, I think I'll just animate the master displacement, just for speed. So next up, I want to animate the text flying in. So let's go to the animation workspace. I'll go into camera view, and I'm going to turn off the modifier by turning master displacement down to 0. And I'll set the frame range. I want it to be about 3 seconds long, so that's going to be 90 frames. And I'll go to the end frame by pressing shift right arrow. And then I want to add a keyframe for both the camera. So select the camera, and we'll do I, and I'm just going to animate the rotation of the camera. So we'll go with rotation. And you can see we've now got keyframes on the timeline. And I'm also going to animate the text. So add a keyframe for the text. I'll do I. And this one I'll do location, rotation, and scale. We'll go back to the camera. Press home. So we zoom in. Press N. Make sure we've got the camera locked. Viewport movement. And I'll go into rendered view so I can see the 3D world environment. And now I just want to rotate the camera. So I'm going to use Shift tilde. Oh, actually, I need to go to frame 1 first. So Shift left arrow, Shift tilde. I'm going to look around, maybe to about here. And then with the camera still selected, I'll press I and another rotation keyframe. And then I need to move the text so it's in view on frame 1 as well. So I'll just use this top left-hand panel that's already set to the 3D viewport, so that I can move the text without moving the camera in the right-hand view. Turn back on overlay so I can see where the camera and everything is. Make sure I've got the camera turned on. Extras, there we go. So I'm going to grab the text, making sure I'm still on frame 1. I'm going to move it into view. So go into top view. I'm going to bring this across. I want to go into front view now and bring it up a bit and press I. Location, rotation, and scale. And if we play this back, the camera now should follow along with the text. We're not getting it all in place, so what we need to do is use the graph editor now to change the camera's speed so that it matches up with this. So we go Control Tab while we're hovered over the dope sheet. This will bring the graph editor up. Click the camera, press home so we can see it all. And now it's the, let's just check, it's the Z one I need to be changing for the rotation. So I'm going to select the two handles for both the Z and the X. We could probably get away with just the Z, but I'll do them both. And we'll just move these handles to the right. And that'll flatten the graph a bit, which means basically the value won't be changing as much over time, so it will take longer to turn to the right. It's going a little bit out of view, so I'll just animate the focal length now just to zoom out a bit. So make sure the camera is selected, go into the camera options, frame 1. For the focal length, I'm going to, let's just see if we can, maybe that'd be quite nice to be zoomed out initially. So I'm going to animate it from there, I, to add a keyframe. And we can now see that in here as well. So I'll just minimize these and turn those ones off. So focal length, we've got a set value now. I'll come across to the end frame. I'm going to zoom in till it's in view. Hover the mouse over the value and press I, so we add a keyframe at the end as well. And now, of course, we need to animate the actual movement of these spheres. So we'll select the text again, and then we'll open up the modifiers tab, and let's hide the object transformation. I'm happy with that now, so I'll hide those in here. We'll just give ourselves a bit more space and press home, so it locks it back in. And just to make the render a bit faster, we'll stop it rendering outside of the camera's view. So we'll choose the camera, go into the camera's properties, and we'll turn under the viewport display, we'll turn up Passepartout, I believe it's pronounced. I always feel like a bit of an idiot saying that. We'll go to frame 90. In fact, I think we'll go a little bit this way so that we've got a little bit of, the camera's going to come to a halt a bit more quickly. So I'll go to frame, let's say 75. I'll turn the camera movement back on as well. I'm going to move, let's just turn the handles off so we can't see those. So we've only got the keyframes now. I'm going to move these to the left. And for the text, I'll do the same. So make sure I select the text, turn these back on, we'll move these across. So the camera and the text are going to stop at the same time again. And then for the text, we'll go into the modifier and we'll start animating this bottom value. So on this last frame here, 75, where the movement stopped, I want it to be 0. So I'll just add a keyframe by hovering over this and pressing I. We'll hide the object transforms now. Let me just move screencast keys up a little bit. Then we'll go to this frame, first frame, and I'm going to change this to be higher. Let's play that back. Oh, we need to add the keyframe first. So let's put it to about here. We'll press I. Now it's going to be coming across. Let's turn the overlays off so we can see it a bit easier. And gradually sort of come into the text, and then it's going to stop. I think I want it to be moving a bit more all the way up until near the end, and then suddenly, go back down to normal. So let's press home so we can zoom in. I'm going to actually Shift D, move that one across the X to about here. And now it's going to be fully moving, much longer. It seems to have gone black. Not sure why. Let's try and turn that off and on again. There we go. Now it's going out of view a bit, so I'm probably going to have to modify the focal length to make sure it's in view at all times. But before I do that, I just want to modify the actual noise of this geometry so we're getting a bit more interesting result. So let's go back to, say, about here, and then I'll open up the main workspace again, into camera view, press home so it fills the screen, into rendered view. And now we'll make the final tweaks to the noise, so I won't speed this bit up so you can follow along. We'll mute this one. I think we'll do it in solid view so it's a bit easier to see. Now that's in the way. So I'll just modify the displacement for the noise 1 and noise 2. A little bit faster, maybe 0.02. Yep, so that's the first one. And maybe we could change the distortion on that one as well a bit, actually. Let's try that. Make it a bit noisier. Alright, so that's that one. And now I'm going to unmute number 2. And I'll mute number 1 just so I can see number 2 on its own. Maybe we'll speed that one up a little bit. 0.1 perhaps. And we'll change the displacement a bit more for the second one. And I think we'll add a little bit of distortion to that one as well. Not too much. Yeah, about there. And now we'll have a look at number 3 on its own. Mute number 2. Now we've got this one. And I think we'll bring the scale down. We'll bring the scale up just a little bit so we've got a bit more movement on there. Yeah. And maybe we'll just bring the distortion up a tad on that one as well. Yeah, I think that's looking pretty good. Now let's recombine them all. So unmute 1 and 2. Well, I think number 2 may be going a little bit too fast there. I'll just mute number 3 temporarily. Yeah, the second one's a bit too much distortion, I think. So let's change the distortion down to 0.5. And maybe change the speed to be a little bit slower. So I'll unmute this one again. And I'll play that back. So we're going a bit outside of view, which I'd like to avoid. So the camera selected, I'm going to go to the animation screen. And we'll make sure we've got the focal length selected. And I'll just hide the others. I'll press home to zoom in. And now let's get this back in view. So initially it's fine. Here it's gone out of view a bit, so I'll just bring that down just a tad. Press I to add another keyframe. I'll keep going across. It's out of view there. And I'll probably just come out a little bit here. Press I. Let's see if that fixes a bit before it as well. It's a little bit out of view there. I'm going to rotate the camera a little bit on the Z axis. Let's bring the Z up, press home so we can see it. We'll add a keyframe, making sure this one's selected. So I only selected channels. This one's selected because it's yellow. And GY, I'll bring that up a bit so we're back to the center. Let's just play it back now. Not bad. It is going out of view a little bit just here. So I think what I'm going to do is tilt the camera downwards, which is going to be on the camera's x-axis. So I'll make sure I've got the x-axis selected. And we'll just get this one now. I'm not going to be careful we don't destroy the rest of it. So I'm going to get a keyframe maybe here and press I. only select a channel. In fact, we might be able to get away. Let's bring that across. Just this one. GX. And I'll bring it across and down. Just a tad. Let's see if it destroys the rest of it. Make the screen a bit bigger. So anywhere within this yellow boundary is what I'm after. Perfect. Alright, so let's have a look at how this looks rendered. Play this back. Nice. And a little zoom in at the end as well. I'd like it to take a little bit longer for that final zoom in. So I'm actually going to extend the frame range a tad. So go into the output and we'll change the frame range. We'll add another, let's say another second. 120 frames, so that's another 1 second. And then it stops here on frame 76. Let's just turn frame dropping on so we're getting the actual speed of the animation, just in case it's skipping any. Probably about there actually. I think that's maybe 100 and, let's go 103. And then we'll bring up the focal length again. And I'll just extend that GX across until the very end so that it continues zooming in after it's stopped. Right, so that's looking pretty good. I think what we need to do now is make it look as though it's bouncing off of that floor and interacting with the HDRI world environment. So we'll come across and we'll add a plane in here. Top view, Shift A, I'm going to add the plane for the ground. I'll rotate it to match where the text is at the end on the last frame. Just go to last frame. I'll scale this right up so that it covers the entire viewport, and I'll apply the scale. Control A, apply scale. Now let's play this back. Make sure that's in view all the time. And you'll notice the particles are now going through the actual plane. If we go into this side view, we should be getting a few frames where the particles are actually coming through the floor, but it looks as though they're bouncing off in here. So that's perfect. And now, of course, we need to make the HDRI world environment show up on this plane so that the plane reflects the right colours onto the text, and also that the text reflects the colours onto the plane as well. So the way we can do that, we'll go into the layout and we'll go into rendered view. And now we'll change this to a shader editor. In fact, we've got one over here, but I'll change this into a shader editor again. So we've got two. This one can be the world editor, and this one's going to be the material for the object. So change it to object mode. It's got no material at the moment, so make sure the plane's selected, choose new, and I want to plug this same HDRI image into the base color over here, but I need it to use the same mapping so that if I rotate the world environment over here, it will be updated in the material for this plane as well. So I'll select these two, making sure I don't select the two either side. I'll press Ctrl G so it makes it into a group. I'll come back out. I'll just name this world. I'll come over here. I'll press Shift A, down to groups, and now we've got world in there. Bring that in. I'll plug this into the base color, and I need to add some coordinates. So it's going to be different coordinates than we used over here. So Shift A, S, texture coordinate, and we need to plug in object. So plug that in there, and now we need to tell it which object to use to project from. Modifying the rotation will break the HDRI, so we actually just need to use the location of the camera. Now we can't specify just the location of the camera, so we'll have to use a second object. So let's come out of here, turn on overlays so I can find the camera, go into normal view, and where's the camera? Just go in here, make sure extras is turned on, cameras is on. Where's the camera? Oh crap! I've rotated the camera viewport. I forgot that each workspace you've got to change the setting in the view tab separately. Let me just try and undo that. With the camera selected, undo it. Oh, we're lucky. Now we turn this off. That's the thing to remember actually. If you've got the camera selected, normally you can undo it. So that's back to how it was. So let's go into rendered view. We can rotate the view safely, and then we'll select the camera. We're going to Shift S, cursor to the selected object, which is the camera, and then we'll do Shift A to add a mesh, an empty rather, to the location of the 3D cursor we've just placed. And if your camera was moving, you'd have to add a constraint in the Constraints tab, but we don't need to because it's stationary, so it's going to work straight away. I'll just change this now to be the empty, and now it's going to project the HDRI from the empty's origin. And then we'll just get rid of the extra shine by turning the specular all the way down. And because the camera's not moving, that empty is going to be in the right place to project from, making sure that the HDRI on the plane matches up with the HDRI of the world environment. Right, so we'll start by turning off the overlay so we can have a closer look. Control B just to isolate this area of the render. I'll zoom in. We can see that the plane, although it's got the correct texture on it, it's a little bit bluer than the environment background. And that's just because the environment is actually casting blue light onto it. Now normally, if I wanted to keep this visible, I would modify the colour a little bit using a RGB node, RGB curve node. Now it doesn't matter in this scenario because I'm going to be using a shadow catcher. So the shadow catcher options are in the object properties. Under visibility, if we turn on shadow catcher, the only thing that's visible now is the shadows. So it's not really a problem in this case. I'm just going to turn this off briefly. The reason is, it's too flat under the text. I want to be able to have sort of the effect of grass sticking up so we get a more realistic result. And there's two ways we could do it. We could make a grass blade and then scatter it all over the place and then use that as a shadow catcher so that we can see the environment on it, or we could use displacement. I think for this tutorial I'll go with the displacement method because it's a little bit quicker. So let me just set it up. We firstly need to, under the render settings, make sure we've got the feature set to experimental. And then this will allow us to add a subdivision modifier, and we'll get this extra option, adaptive subdivision. We don't want any levels standard sort of subdivision, so I'll set this to 0. I don't need any smoothing either, so I'll set this to simple, just to make it as fast as possible. And how this works is, it will subdivide the mesh based on the number of pixels on that area. So if we've got, for example, at the moment it's doing one subdivision for every pixel in the final render, and in the viewport it's doing one subdivision for every 8 pixels. That means close to the camera we'll get more subdivisions, further away we'll get far less. For example, 1 meter here might be 1,000 pixels, so we'll get 1,000 subdivisions in the final render. Further away, 1 meter might be 1 pixel, so we'll only get 1 subdivision. That will save a lot of memory and it will still look perfectly fine. So with this setup, I need to make sure I set the viewport to be the same number of pixels as the final render, just so I know what I'm getting. So I'll go into the render settings, I'll go down to the subdivision area, and I'll change this. I think I'll set them both to 4. And then if we go back to the modifier, you can see we've got every 4 pixels we're going to get a subdivision in the render and in the viewport as well. So now we've got sufficient subdivisions, we can now start displacing the mesh to give the effect of grass. So in the material, we'll Shift A, S, we'll add a displacement node, and Shift A, S, a noise texture. We'll plug the factor of the noise into the height, we'll plug the displacement into the displacement input of the material output. We'll need to increase the scale, so we'll go with something like 500, and we get an effect, but we're only getting a bump map. We're not getting the geometry actually displaced. And to fix this, we'll go into the material settings, down to the bottom, under settings, and then under surface, we've got this displacement type. We can change this to displacement only. And now the displacement is having an effect. Obviously that's way too strong, so I'm going to change the scale to 0.2, so it doesn't stick up as much. And the blades of grass are too fat, so I need to change the scale here to much higher. But the problem is, displacement, the subdivisions are only calculated either when you start rendering or when you turn this off and on, the adaptive subdivision option. And because I'm zoomed in, this isn't the result we're going to be getting when we're zoomed out. So I'll make sure I zoom out first, Control Alt B to unhide everything. I'll press home. So we've now got the actual view we're going to be getting in the render. And now we can start tweaking these settings. I'll just turn the adaptive subdivision off and then back on, so it refreshes the subdivisions. And now we can start tweaking these. Maybe 5,000 might be enough. Yeah, that's looking pretty good. Doesn't have to be incredibly thin blades of grass, but you can take it higher if you want to. But if you do that, you may need to come into the render settings and just decrease this value so that you get more subdivisions per pixel. For me though, I think that looks pretty good. So what I'll do now is go back into the object properties and I'll turn back on the shadow catcher, and there you go. I think what I'll do as well, I'll just increase the scale to 50,000 so that if I want to increase the dicing rate later or decrease it, I don't have to change the noise texture again. Now every single frame, this subdivision modifier is going to be updated. And if the camera's zooming in and out or rotating around, then the result, the subdivision, is going to be different on the plane, and that's going to result in this grass sort of moving about and flickering. To avoid that, we'll create a second static camera in exactly the same location as the rendering camera, and because that camera won't be zooming in or out or rotating, the subdivision will remain identical each frame, and that means we'll get no flicker on the grass. So let's create that camera now. We'll turn on the overlays. So this is the current camera. The 3D cursor is already in the right place. So I'll do Shift A, and I'm going to add another camera. And we'll make sure the new camera is aligned to the rotation of the original camera on the frame when it's stopped near the end. And we'll go across to the constraints, and I'll just say copy rotation, choose the rendering camera, and then we'll apply this by pressing Ctrl A while we hover over it, and now the camera's locked into place. For the subdivision, the adaptive subdivision, to use the other camera, we need to tell it to, in the render settings, under the subdivision, dicing camera, and then we'll tell it to use that new static camera so that the subdivisions always remain identical. If we play this back, let's go to the last frame, Ctrl B, I'll just render a tiny bit, or enlarge it, and go back a few frames at a time, and we can see that grass is static, so there's no movement on the grass basically. Perfect. So Ctrl B so we can see the full thing, press home, and what I want to do now is just get a sort of an idea of how the final render is going to look. So I'll go into the geometry node editor, and I'm going to replicate the number of particles that we're going to get in the render in the viewport, just so I know what I'm going to get. Just turn overlays off. If I set this now, I'll just save it first in case my computer keels over and dies. I'm going to set this to be 0.3, so it matches over here. And we're getting 37,000 now, which is getting way more. And I'm going to change this to 1, so that it's the same radius that we input over here. So they're way smaller. And now we'll change this to 1,500, we should get way more. 3.1 million, and now we're getting a much more dense look in the viewport. So I'm thinking actually, I think I'd like them to be a little bit bigger. I'm going to go with 0.008. Let's see what that looks like. I think that looks better. I'll just test a few different frames, see how it's looking. Yeah, I think that looks pretty good. Okay, so because we're using a shadow catcher, we need to set up a few passes for this to work correctly. So go into the view layer properties, right down to the bottom, we need to turn on the shadow catcher pass. This will ensure that the shadow catcher will get indirect lighting from the rest of the 3D scene and reflections as well. We're not using reflections in this one, but without this turned on, you'd only get black and white reflections, which would be rubbish. So we'd also, because we've turned this on, we're going to need to turn on the environment pass. And I'm going to turn on the denoising data as well, so that I can denoise the shadow catcher separately. Okay, and then we're going to go into the render settings, and we need to set up the samples. So probably for this scene, we can get away with maybe 0.03 for the noise threshold. Max samples 512 should be fine, and min samples I'll set something like 16, just to make sure we get enough samples in the inside there. And for the denoiser, I'd recommend to turn on the Open Image Denoise. Now, if you're using Turbo Render, which comes with the Turbo Tools add-on, instead, we'll just minimize that and we'll go to Turbo Render Options. We'll turn this on, and the settings I would use for this one are very dirty. Interior, I'll turn that on because there's a lot of indirect lighting between the balls. Draft Rapid should be fine for this one because it's such a simple scene. There's not really much information on the various passes. Sample preset, crap again, should be fine. Turbo Render can do a really good job even at very low samples. So this is actually just 16 samples. And then I'll turn on Enhanced Textures just to give us a little bit of separation in the denoising process between the different elements. I don't want to prevent fireflies because it's going to take away the brightness that I'd like to keep, but I am going to optimize the HDRI because that should reduce the memory consumption of the HDRI quite dramatically and save a lot of memory during render. Visible to camera, we've only got the diffuse and glossy material on this, so we don't need to enable any of the others. We have got the world environment though. And then finally, I just need to set up the output location for the cache. And because the movement is so complicated and fast and all over the place of these particles, we're probably going to get a better result if we use the render time motion blur rather than using the vector pass in here. So sometimes I would use a vector pass and then add motion blur in the compositor. But for this particular scene, I think it's going to be better. Even though it's going to render, it's going to take twice as long to render most likely. We're going to get much better results if we turn on motion blur in the render properties instead. So let's go down to motion blur. I'll turn it on. I'll leave it at the default settings. And extremely importantly, we need to go down to color management and make sure this is set to standard, none, 0 for exposure and 1 for gamma. This will ensure correct workflow in the compositor. And then finally, we need to tell Blender where to save the render. So in the output properties, I'm going to change this to be a MPEG video, and I'll save it to the same folder as the blend file. So I use // and I'll give it a new folder. We'll say render output, and then I'll give it a name, tutorial _ render. So 1920 by 1080. That should be okay. I might add some audio in. Yeah, let's grab some audio. So I'll go to this website called freesound.org, and I'll make sure that I choose, let's just search for windy day or something like that. Let's say park. So this is going to bring up all the sound effects from the park, and I'll make sure I choose Creative Commons. This is so I can basically use it however I want without worrying about, getting in trouble. And now I'll just play through a few, find one I like, and then I'll download it. And then once we've downloaded it, we'll go back to Blender and then basically just drag it in to the video sequencer editor. Click on the plus. Under video editing, we'll click video editing again. I'll turn off these seconds because it always confuses me. So under view, show seconds, disable that so I can just see the frames. I'll drag in the new sound I've downloaded. And we'll turn on the waveform so we've got a better idea when we start dragging it around what that audio is going to contain. And then I'll just drag it around, playing back until I find something I like the sound of. And if you find playback to be quite slow, just turn off the modifier for the text and that'll speed it back up temporarily. I'll go back to the video editing workspace and then you'll get much faster playback. Much better playback. I'll just find a bit of light. So that's the audio setup, and in order for that to be burnt into the actual rendered video, we need to go back over here, down to the output settings, and under encoding, we need to make sure, let's just turn that off now. We need to make sure we turn audio on for the audio codec. AC3 or AAC should be fine. I'm going to make this MPEG-4 instead of Matroska, just so it's compatible with DaVinci Resolve. And I mustn't forget, I've got to turn the particle system back on as well. Okay, and then over to the compositor, and we'll start setting this up. We need to turn on use nodes, and for you, you should get a couple of nodes appear. For me, I'm going to have to add them manually because I've used this file before. So search for render layers node. Shift A, S, composite node. So this is the node that outputs into your final image sequence or video. So I'll plug that one in there. Press Control Shift and click on this one so we get a viewer node, and then I'll hold Shift down, right click and drag to consolidate those into one new reroute. I'll turn on the backdrop. If I click on here, we can see where the backdrop is. And finally, I'll change this into an image editor so that we can see the render as it happens. Make sure this is set to render result, and I'll make that a little bit bigger as well. Okay, so we're ready to render. So press F12, and you should get a notification up here how long it's going to take and what the current time is. So it's going to take a little while because firstly, it's probably going to take around about 13 seconds or so for the actual particles to be built. And then we're going to have to wait for the render time as well on top of that. And the render is going to be quite long, as I say, because we've got motion blur enabled. Alright, so 40 seconds, that's fine. But you'll notice, because I'm using the shadow catcher pass, we don't have the shadows in the final image. Now I'm just going to delete the Turbo Tools cache quickly so I can show you how to do it if you don't have Turbo Tools. So I'll just uncache this. Now you can see this is the result you're going to get without Turbo Tools. So let's build it up. Shift A, S, mix. And this will change this to 1 to multiply. And then Shift A, S, alpha over. We'll plug this one in here. And then we need this one to go in the bottom, so the image into the bottom. And then we need the environment to go into the top. Now what we need to do is bring in the shadows. So we put this one over here. And then we're going to multiply this with the shadow catcher. There we go. So we've got the shadows back. And if you're using Turbo Render, by design, Turbo Render doesn't denoise any of the passes that aren't used to rebuild the combined image, just so you can keep the flexibility to denoise things in a different way if you want to. If you're not using Turbo Tools, then the shadow catcher pass will be denoised for you. So obviously I'm using Turbo Tools. I'm going to add a denoise node. Shift A, S. We'll drop down a denoise node. And I'll just set this to none. We'll leave HDR on and just plug that in there, and that will denoise the shadows as well. I'm just going to bring the Turbo Tools cache back by clicking refresh all. That'll bring up the cache and it will automatically move the wires from the render layers node to this one. Alright, and then you'll see we're getting this part denoised as well. So we've got all the shadows, everything set up, we're ready to go. Now with Turbo Tools, we don't actually need this one here. So I can delete this one. Let's get rid of that. And plug that one straight in there. That's because Turbo Tools automatically builds the environment back in for us. And then finally, we want to make sure we get the image looking as good as possible. So what I'm going to do is come over here, just make a bit of space. In the image editor, I'm going to turn on the scopes and I'm going to change the waveform to be parade. So this will show us the levels for all three, red, green and blue. Let's just zoom out a bit. The aim is to get it all between 0 and 100. If you get it above 100, then you're going to start getting clipping like we can see on the blue channel here. So what we need to do is just move this across, make this a bit bigger. I'll turn up the waveform opacity so it's easier to see on the video. Right, Shift A, S, RGB curve. We'll drop this in here. And generally, you need one for the black level, one for the white level, one for the gamma, and then one for the contrast. So in this case, we probably don't need to mess with the black level because it's all, if we look on here, the lowest pixel values are already at around about 0. So there's nothing below and there's nothing way above it. If they were way above it, it'd be washed out. If it was below it, we'd be getting too much contrast. So I won't do one for the black level. I'll just do one for the white level, the gamma, and the contrast. Right. And this is something you should do on every render, basically. It will give you a much better result and give you much more control than if you use one of the automatic compositing, color space transforms like Filmic or AGX. I think AGX is the new one. And it's so easy, it'd be daft not to. So I'm going to drag this one down until this area comes below 100. Now at the moment this is quite slow because I've got the denoise node turned on. So I can either mute it, we'll get the noise back, or if you're using Turbo Tools, I'll just cache it. So I'll set the cache resolution to 100%, select the denoise node, choose cache uncache, and now this is going to cache that denoise node for us, and it will also get cached every frame when we render the full animation. So I'd definitely recommend you do this if you've got Turbo Tools installed. And now we no longer need to wait for that denoise node every time we make a change. It's going to be instantaneous. So we've got it all below 100. It's gone quite dark though, and you'll see the difference. If I just mute this, you can see it's become much darker, but we're getting more of that detail back in the clouds up here, for example. We can now see all the detail. So to boost up the gamma, or to make it look brighter without sort of introducing clipping again, we'll just use this one and bring up the gamma, the mid-range, until it's nice and bright. Just get that how you want it. And then we'll add a bit of contrast back using this one and this one, just to bring that up a bit. And basically just get it until you've got the look that you like. And once you've got it set here, you can make minor adjustments using the factor. So if it's a bit too strong, I just put 0.5, and we're going to get a much less of an impact. Maybe I'll go with 0.8. Let's go. Actually, let's go I think 0.6 looks quite good, pretty good. And I think just to be thorough, in case anybody does need to modify their black levels, I'm quickly going to show you how to do that, even though I don't need to use it for this scene. Shift D. I'm going to set this one back up to the top. And for the black levels, what we'd do is, if the black levels are too high, so the lowest point on the graph is, nowhere near 0, you'd want to bring the black levels down, in which case you drag this side to the right. As you can see, that's going to make them go below 0 in this case, and then you can control that again with the factor. So 0, 0.1, 0.01, etc. And so you've got it exactly how they like it. So I could probably go with like 0.001 for this case. Now, if it's the other way around, if the levels are going below 0, like they are now, so Shift D, I'll duplicate this one across, and now what I'll do is I'll get this and bring it up until it's above, and then again I can use this to dial that in, so maybe 0.99, just to bring it down a tad. So there we are, that's how you would do it. Obviously you'd only do it with 1, you wouldn't do it with 2. So I'll just delete these, I don't need them. Control X, and we're back to how we were before. So everything's set up, we're now ready to render the full animation, and again, if you are using Turbo Tools, I would definitely recommend you cache the denoise node before you start rendering the animation, so that afterwards we don't have to sort of wait every frame for this denoise node to recalculate if we decide we want to republish it with like a different audio file, or if we want to add some effects and things like that. In fact, actual fact, let's just add a quick effect. So Shift A, S, put down a lens distortion. I'm going to give it a tiny bit of dispersion, 0.01 perhaps. Let's just see what that's done. Let's hide the scopes now over here, and I'll zoom in, and you see what's happening is we're getting a little bit of a chromatic aberration around the side, which I think adds a little bit to the realism, but you don't want it crazy high. So if I go something like 0.2, like it's going to be crazy high, then you're going to get, it's just going to look too weird. And we're also going to get this blue sort of band or green band around the edge, which we can hide by choosing fit. And that will make sure the image fits in and we don't get that frame around the image. So that's way too high, of course. I'm going to set this to 0.05. And if it's a little bit too saturated for you, a good trick you can use, if I just mute this temporarily, Shift A, S, put down a mix node. We'll plug this one in here. Shift A, S, BW, so RGB to BW. I'll plug this one in here. And this is a much better way of desaturating your image. And I'll plug this one in now to the lens distortion instead. And you'll see we've got a black and white image. Now the difference is, if we do it this way, when it turns black and white, we can still differentiate the different levels of the different colours, because some colours are perceivably darker or lighter than others. Let me just show you what I mean. Shift A, S. If we use this with a hue saturation node instead, So I'll plug this one in here. Let's connect this one up. And I'll set the saturation to 0. Look at the difference. So this one is with the method I've just shown you. And you can see we maintain those perceived differences in levels for the different colours. Whereas the inbuilt hue saturation node will actually lose those differences in perceivable levels. So this is without. You can see the green is much brighter perceivably. Let's say this area is quite dark. So that's making this area quite bright, whereas this one is looking the way it should. So I'll delete that one. And I'll just dial it down to maybe 0.1 or 0.2, just to try and make the saturation look a little bit more realistic. I'm going to go 0.1, I think. So I'll reconnect this one. I'll turn this one back on. We're all set up, and now we can render the animation with Control F12. And I'll just make this a bit more visible over here. Save the file, Control F12. Alright, so that's finished rendering. Let's look at the result. I'll go into view the published animation. If you don't have Turbo Tools, you can get the same thing in here in the render menu, view animation. And that just saves us messing about opening VLC or something like that. We can view it directly inside of Blender. And just for an added bonus, for those of you that do use Turbo Tools, I'm going to show you how you can recreate. If you find something wrong with the render, for example, the audio is too quiet, or you're not happy with the amount of contrast you've got, you can very quickly republish your animation. So let me just show you that. Just turn off in the layout, just for added performance, I'll turn these modifiers off now. We'll go back to the compositor, and let's just turn this off temporarily, press M, and I'll try playing this back in real time in here. Let's turn the viewer node on now. Play this back. You can see we can actually play back in the compositor backdrop. So that's one feature of Turbo Tools. Something else we can do, of course, we've already looked at, is cache an entire block. So if this is a little bit slow, what we can actually do is cache after this point during playback. So let me just add a cache node here. I'll make it 100% cache. Cache that. And then up here, I'll put, we'll just press play. Nothing's going to happen. It's just going to keep loading the same cache file. What we need to do is click on the validate cache button. And now during playback, it's going to cache all of those nodes downstream of it for every single frame. And I'll just make sure to turn off frame dropping, so we're caching every single frame. And I'll just speed the video up a bit so you don't have to wait for this to finish. Alright, so now we've got it fully cached and it's playing back now much faster. I'll just change this to frame dropping again, or sync to audio. And now we're getting the full speed video frame rate directly in the compositor's backdrop and also in the image editor as well. So that's a good feature. Now also what we can do is continue compositing now in real time. So if we're not happy with the result, let's say on this frame here, let's bring up the scopes again over here. We'll play this back and you see this is actually updating now in real time. So we can just keep an eye out and make sure there's no frames where we're going above or below. And if I want to, I can even start adding nodes. So I could do an RGB curves if I want to add a bit more contrast. And we can even do this during playback, animating different values for different frames if necessary. And when we're finished with any changes that we might want to make, I'll just go across, I'll just pause it briefly. What I can do then is go across here to the output settings. I don't want to overwrite my original file, so I'll call this Turbo Render V2. And then under the options for the publish, I'll say do a quick publish. So that means it's going to use the cache we've got here. And that's good because it means it'll be much faster because it doesn't have to calculate all those nodes downstream of the cache node. And this is not sped up, this is the actual publishing speed at 1080p. And in less than sort of 10 seconds, we've now got a second copy of the animation, which we can look at if we click on View Published Animation. So that was just a quick bonus for those of you that have got Turbo Tools, because I am aware that a lot of people don't know that Turbo Tools comes with all these additional features. They buy it just for Turbo Render to get faster cycles renders. But yeah, it's really useful, really powerful. and particularly if you're going to take your work to the next level and start doing a bit of compositing instead of relying on those, AGX and Filmic automatic composition systems. So that's it. I hope you've enjoyed the video, and I will catch you in the next one.